Hey guys, hello everyone. So today we will learn about the projectile motion. Okay, first we will look at the definition, then we will see that there are some formulas, okay, to calculate maximum height, time of flight, and the range. Okay, these 3-4 terms we will learn. At the same time we will try that we don't mug up all the formulas. Rather we will solve with the very basic formulas. Without using any formula we will try to solve the questions. Okay, so suppose this is the particle which will fly into the air starting from this point. Let's call this axis x, this axis y. This is the particle. Velocity given is v, and there is some angle from the horizontal axis which is theta. So the path of this particle will be like this. Okay, this path is known as projectile path. The path of the particle is known as projectile path. Okay, now suppose velocity is given and we have to find this height and the time taken by the particle to reach this point again. Okay, and let's say this distance is r. Okay, so we have to calculate h max, r, and the time of the flight. These three are very important and you may remember the formula also. Okay, but I will try to solve this question without using any formula. Okay, so let's first see the formulas. So this is the list of formula. Okay, this is the formula list. You must remember this because sometimes in the objective questions it directly पूछा जा सकता है. Okay, now clear this thing and suppose we have a particle which is thrown at this point, thrown from this point, and velocity is 10 meters per second. This is x-axis, this is y-axis, this is theta is, let's call 60 degree. So this particle is having one velocity but two component of that velocity. Let's call this is x component, this is y component. Vx is simply v cos theta and vy simply v sin theta. So if we put v equal to 10 and theta equal to 60, then 10 into cos 60 is half, so this is 5 meter per second. Similarly, if I put velocity here and theta here in the sine function, I get this to be 5√3. Simple. Okay, now suppose this is the path, the particle, and we have to calculate this height and time taken by the particle during the flight, also known as flight time, and this range. We have to calculate these three parameters. Okay, so one thing we can do is we can directly use this formula. Okay, we will get something in return. Okay, so let's see without using this formula how we can calculate the height, range, and time t. So if we use if we use this formula that v equal to u square plus 2a as, and this gravity here, this is approximately 10 meter per second square if we use. So if I use this equation from this in the vertical direction, means in the y direction, this is the displacement in y direction, then what I get, this u at this point, if I there is initial velocity is how much? This is the initial velocity 5√3. Okay, sorry. So the initial velocity is 5√3. We have to take square of that. And when this particle reaches at this point, then it is having only one component in x direction, which will be 5 meter per second. There is no velocity in vertical direction, so we can assume that we can say that vertical velocity is 0. Okay, now put 0 here, and then this 2, and gravity is acting in the vertical direction, which is negative direction, so minus a equal to 10, and s, what is s? S equal to this height h. So if I calculate h from this equation, then I get h to be square of this is 75 divided by 20, which is nothing but 3.75 meter. Okay, so this is our h max. I write h max here, 3.75 meter. Let's erase this thing, these arrows. Okay, so let's erase this thing here. Now we will use another equation, and we will try to get what range. No, first calculate time. First calculate time. So time is this time. What is time? Time is whatever time the particle take when it thrown at this point and it reaches at this point. Okay, so what we can, this path is symmetric, and what we can do is we can calculate the time taken by the particle when this is here and when it reaches here. So the time taken by the particle in between these two positions, and we can double it. So the total time is equal to 2 into t. Okay, so t is time taken by the particle when it reaches at this point, which is at the maximum height point. Okay. Now to get this time, we can use this equation, which is By equal to uy plus at. This is y component when this particle reaches at this point. So y component at the point where the height is maximum, this is 0. Uy is how much? Minus the plus 5√3. Acceleration is negative, take it 10, and this is time. So from here you get t equal to 5 into this √3. Okay, so what you get? √3 by 2 seconds, and total flight time will be 2 times of this, so which is 1.732. Okay, put it here, 1.732 second. Now calculate the range. So clear all these things. Now to calculate the range, now we are calculating the range. Range is simply distance traveled by this particle in x direction. So what is the velocity in x direction? So Vx and time, total time will be equal to range. What is Vx? Vx equal to 5, total time is this 1.732. okay, so this will be approximately how much, like 8.5 meters. 1.7 into 5 equal to 8.5 meters. So this is range. Now what we will do is we will use these formulas to calculate the values again. Simply clear all these things, also clear these things so it looks good. Okay, so now this was the original question. Okay, now we put velocity and theta in these three formulas. So Hmax we get Hmax equal to u square. What is u? Equal to 10. So 10 square into sin theta. Sin theta is root 3 by 2, square will be 3 by 4. This is 2 and g is 10. How much? So this is 10, so 10 gaya, then 2 to 5, this is 5. So this is 15 by 4, which is nothing but 7.5 meter. See? So this is verified. Now t equal to 2. What is u? u 10. Sin theta equal to root 3 by 2 divided by g. G equal to 10. This 10 is 10. 2 is 2. This is root 3. Root 3 equal to 1.732 seconds. This is also verified. Now okay, now calculate range. Range from this formula is u square. What is u? U equal to 10. U square into sin 2 theta in sin 120 degree divided by g10. So this becomes 100 by 10 into sin 120 is how much? Root 3 by 2. So this is 10 to 5. So this is 5 root 3, which is approximately 8.5 meter. This answer is also verified. So what we can say that if we don't use these formulas and simply use basic equations, we can also get the Hmax, T and R. Okay. Okay, thank you.